Okay, I guess we'll get started. So hopefully everybody's working on their prototypes, and what's going to happen next Monday is that we're going to take all your prototypes and then swap it among people in the class to do heuristic analysis of the prototype that you made. So each person will get 2 other students' systems to evaluate. And the particular kind of evaluation that we're going to do is this heuristic analysis, which is an expert technique for analyzing systems with a set of guidelines. And so one of the reasons to do this lecture early is to try to make sure that you know what guidelines people are going to be evaluating your system against, and maybe you can use these to improve your system as you're building it. So ideally, you'll take these guidelines and try your hardest not to violate any of them as you're doing your designs. So ideally, everybody will turn theirs in by Monday at 1:30, and the TAs are going to immediately try and run them Monday afternoon, just to make sure that they actually execute and that they can be distributed. And then we'll make up a spreadsheet that will determine which other people get your assignments, and we'll send them out hopefully on Tuesday. And then you'll have through the holiday weekend to do this evaluation. It's usually pretty simple and straightforward, and most people get a really good grade on this one. It's not too onerous. So what is this heuristic evaluation method? It's basically pretty straightforward. An expert analyzes an interface based on a set of guidelines. So you're looking for violations of these guidelines and trying to recommend some improvements of the interface based on your expertise. It's called an inspection method because you're basically inspecting the user interface. And one of the advantages is that you can do the entire interface, because you can go through every screen, you can go through each feature, and do this analysis comprehensively, which you can't really do in a user study. It's too hard to get the user to do each part of it. But because it's an inspection method, it obviously depends a lot on the skill of the person doing the evaluation, on their personal opinions and their ability to find problems and to think about which of these problems are worth addressing. So one of the reasons to give it to you guys is, so you can have practice of this method and also get some feedback about how well you're doing at finding problems with other people's interfaces. It's called the discount usability inspection method because it's so cheap and easy to do. The name was given by Jakob Nielsen, who picked out the particular heuristics that we're using. And if you read this section of the textbook, you'll see that they're based on his work on identifying which particular heuristics make a lot of sense to use as evaluation. And he found in some of his studies that it's almost a factor 50 cheaper than deploying the system without doing this. So the idea is that it only costs a small amount of money to do this inspection, if you count how much people's time is worth and so forth. And then the cost of not fixing these problems and having them actually deployed in the field and then fixing them later, obviously much more expensive. So as I've said, it's a systematic inspection of the system by an expert. And one of the reasons I like doing this homework is that you'll see that the 2 people who are evaluating your system will typically come up with different opinions, different lists of violations, different recommendations for things to fix. Obviously, if you make a really bad error, hopefully both people will notice it, but hopefully you'll be paying attention to these guidelines as you're doing the design and won't make any really awful errors. And instead, there'll be kind of subtle errors or interesting issues that your classmates can identify. In practice, in the professional world, it's the same idea that if you do multiple evaluators of your interface, then they'll do a much better job of finding all the issues and recommending good things to fix. Another study looked at the difference between having engineers, computer scientists, software engineers, do this kind of evaluation compared to HCI professionals. And the professionals got almost 3 times as many of the errors or problems in the interface as the computer scientists. And that's just because of the experience they have with all sorts of different interfaces, understanding what sort of things to look for better, and also the severity of the kinds of things that they're supposed to be identifying. When you get this result, and as we go through this you'll see, you end up with a long list of problems. What do you do with those? Well, ideally you would fix them all, but in practice that's usually not practical, that some of them are too hard to fix, some of them aren't particularly useful as for the current version, and so it's important for the designer then to decide what to do about these. So Nielsen did this kind of analysis that we saw before in terms of user studies of how many experts are really worthwhile. And the basic result is similar to the curve we saw before. Then after about 4 people doing an evaluation, the curve really flattens out and you don't get a lot of new information from the 5th and 6th and 7th people. That they tend to pretty much give you the same results, and the maximum in terms of the expense and value is at 4. So we're only doing 2 in the class, but on the other hand your interfaces are pretty simple. This is kind of more professional level systems that might have 2 or 10 times as many pages as the one that you guys are doing. So there's a very good reference online about how to do this. It's been fairly consistent throughout the years, and so there's a good coverage of this in the textbook, but there's also good coverage online. If you try to do this homework without looking at either of those, you're bound to fail. So it's definitely important to read up on it. In the more, official, professional way of doing this, it's often the case that the evaluator will wonder about something, and then it's perfectly reasonable for them to ask the designer, well, why did you do it this way? Or I think that this is wrong for this reason. What do you think about that? And so it can be a discussion, unlike in a user study where the designer is not allowed to really answer any questions from the user. In this kind of inspection, you are allowed to engage in a dialogue. We're kind of doing that indirectly through the homeworks, in that you're going to write down stuff and then the designer is going to write down their answer. But it's in real life you might have more interaction or have some particular questions. As we require in the homework, in every homework so far, it's in real life you would also supply something like scenarios or use cases or the test script or things like that in order to show the evaluator what sort of thing you had in mind for this interface. So the hope is, as designers, that you will take a lot of these guidelines and keep them in mind as you're doing your design work. So and there are lots of guidelines in the textbook. In chapter 22, there's like 200 different guidelines. There's specific guidelines that we're going to talk about in the rest of the lectures. Specific guidelines for the web, specific guidelines for international user interfaces, specific guidelines for mobile user interfaces. So there are lots and lots of guidelines besides the 10 that we're going to use here. And maybe somewhat surprising that all of these guidelines really stand the test of time. That, you can imagine that the user interfaces have changed drastically since the 70s, since before the Macintosh came out, or even in the Macintosh era. And you would think that guidelines that were designed for desktop PCs or for the Macintosh wouldn't really apply so well to, say, an iPhone user interface or a web interface. But it turns out that in some of these studies, most of the guidelines are still valid after 20 years. Well, why is that? Well, people are still people, right? People still cannot read things that are smaller than 8-point type. Or people can still not click on buttons that are too tiny. And the contrast, that you need in order to read text is still pretty much the same, no matter what sort of device you're working on. So a lot of them are kind of based off of these fundamental human principles, and they apply across all kinds of devices. And that's one of the kind of morals of this, or themes of this course, is that the methods that we're teaching you really should stand the test of time. You can use them today, and you should be able to use them in 10 years, no matter what the computing environment of the future looks like. As long as people aren't, robotized or something, they'll still have the same perception and the same motor capabilities, and so hopefully the same mechanisms will be relevant. Some of these old guidelines were no longer relevant, like, if you have a character terminal, then don't do this. Well, nobody has character terminals anymore, so those are totally irrelevant. But only 2 of them actually turned out to be wrong, in the sense of, oh, you really shouldn't follow this guideline anymore because people have, because the interfaces have changed. So here are the 10 that we're going to be discussing in detail in this lecture and also in the homework. And so these are the ones that you're going to be applying when you do homework 5 starting next week. These are on the web and in this chapter. And I'm going to, in the rest of the lecture, pretty much be going through each of these in turn. But as I mentioned, there's an awful lot of more guidelines that you could follow. And following all of these would be a great idea. Memorizing them all and applying them would help you do better interfaces. But it turns out, of course, that nobody can really remember all of these. And this is just the first page. There are many, many pages of these. And some of them are very high level and abstract. Make cognitive affordance visible. Help users determine actions with effective content, meaning, and cognitive affordances. So that's, makes a lot of sense. Who would violate that on purpose? But it doesn't really help you very much to know what to do. Some of them are very low level. Avoid vague and ambiguous terms is a high level one. Provide clearly marked exits is incorporated in some of those, and the other ones. One of the things that you get to be as, if you take an HCI course, or if you, a more serious, if you study HCI for a while, is that you begin to kind of internalize these and just apply them naturally without having to memorize this whole long list. So at this point, I certainly couldn't come up with all 200 of these guidelines, but when I'm designing an interface or evaluating an interface, I kind of have enough background to apply them just organically. So it just keeps going on and on. Another thing that's interesting about these, and we'll see these in the other guidelines as well, is some of them conflict with each other. And that's, part of the whole point of design, and why design is a creative process, is that as a designer, you're always being asked to make trade-offs, to have a whole collection of constraints that are general constraints like these, and specific constraints for your particular product, along with financial constraints like how long you have to decide and design, and constraints about what features you need. So the problem with these guidelines, as well as the ones that we're going to be talking about in detail, is that you can't necessarily optimize them all at the same time. And so part of the experience, part of the difference between a good designer and a poor designer is having good taste, good creativity, in order to know which ones to violate in favor of, matching other guidelines. So let's go through the 10 that Nielsen has identified and that we are using in your homework. So the first one is called visibility of system status. And by the way, you'll notice that a lot of these are very broad and can cover a lot of different issues in the same requirement. So visibility of system status means that users should always know what's going on in the system. That one way of thinking of it is if you leave the system and come back to it, you should be able to tell what you were doing just by looking at the screen, right? So another way of thinking of it is that if the system ever tells you anything, it should be very clear what it's trying to tell you. So keep the users informed about what's going on. So in the web page, you'd want to know, what web page are you on? So if you're in the middle of buying something, what were you trying to buy? What step are you on? If you're in a camera, what page of the camera navigation are you on? How do you get back to the original page? If you're doing some kind of settings, what setting are you fiddling with? Things like that. Sometimes it's as easy as having a title on your pages to make sure you tell people what page of that system you're on, or a progress bar to show what step you're on. Things like that. Another aspect of this is having appropriate feedback. So if the system wants to tell the user something, it's clear what they mean. So what the system is doing and how input's being interpreted. So one example, I was a consultant for this company which has not surprisingly gone out of business, which I'll use as a lot of examples in this talk, where they had this product with a whole host of usability problems in it. One of them was that when you group things together, then there were all sorts of interesting properties assigned to the group. And if you tried to ungroup it, then all those properties were lost. And that was not undoable in this system. So because this was a destructive operation that wasn't undoable, there was a question whenever you tried to ungroup, it would say, do you really want to ungroup? Without ever telling the user what the implications of doing that ungroup would be. And most users would say yes, because they just told the system to ungroup, right? And then they'd say, oh my, where did my properties go? And they would be surprised that there wasn't any of this associated behavior. You can kind of get that situation in PowerPoint, actually. So if you have some stuff, say this, and I try and group it, oh, it won't let me group the title. Guess I'll have to come up with two new things. So if you have, let's pick a couple of things. So if we have these two guys and we make them into a group, and then one thing you can do is apply an animation to it. So now if I click, where did my mouse go? There we go. Then they'll fade in, okay? So, but you can do much more complicated things than just fade. If I ungroup them, then that fading has gone away. They just appear, right? So this is an example of that kind of thing where the fading operation is attached to the group and disappears without any warning. Luckily in PowerPoint, this is undoable, so if I just undo, then it comes back, and so it's probably okay that it doesn't warn me about it. In this other system, there wasn't an undo for this operation. So that's the one way of thinking about this is that any time there's any kind of prompt or request, that it be entirely clear why you're asking, what are the implications of saying okay, what are the implications of saying no, right? And probably you've all come to this kind of thing where the computer asks you something and you say, why is it asking this? What does it mean if I say yes or no? That's one of the things that comes under this. The next one's match between the system and the real world. And this encompasses a whole bunch of things that involve understanding where the users are coming from, trying to provide things in a way that makes sense to people, and not necessarily in the language of the computer or in the underlying system. So technology in the user's language, don't use computer technology. Another aspect of this is putting the language in terms of the user and not in terms of the system. So if you say you have bought, or we have sold you, right? So if we say we have sold you, then who's the we there? Is it the computer? Is it the company? It's better not to try and anthropomorphize, make the computer seem like a person. So it's better to put it in terms of the user's perspective and telling them what they have done, but rather than what the computer has done. Obviously, you want to avoid techno jargon, any kind of language that has to do with the computer. So for example, if you have a collection of things that has fixed length, you wouldn't say array is full as the error message. Because certainly from the programmer's point of view, that's really the problem. The array has filled up. But from the user's point of view, they don't have any idea what an array is, right? So they just know that they were trying to do one more thing, and all of a sudden the computer won't let them do it. So avoid using the kind of terminology that refers to the implementation, and stick to things that are relevant to the user's point of view. Here's an example. Mail server query results for Hartson send invalid spawn ID 6 while executing send to the spider file, blah, 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 right? So there's all sorts of computer terms there that maybe a programmer understands. This might be useful for a programmer if they're trying to debug this problem, but obviously it makes no sense at all to the end user. Here's another one. When you're trying to print, there was an error writing to LPT1: for the printer HP LaserJet 6P 6MP PostScript. The printer is out of paper. Add more paper. So, why bother with the first line, which has all this computer jargon that has there's nothing that the user needs to do about the fact that internally this was implemented with LPT1. Really, all the user needs to know is the printer's out of paper. Fill up the paper and then hit retry, right? It's another example where there's kind of useless extra information that talks about the computer level. Most file names these days allow you to type in full-length names. Back in the old days, you could only use 6 or 9 characters for names of files. But you still see that a lot with things like usernames or part IDs or things like that, where people are really required in some sense to abbreviate. So you want to allow full-length names and preferably allow arbitrary characters in their names, because there's kind of no telling what kind of special characters people would like to enter. Here's a classic one that kind of falls into this category. There was a system that was doing a bunch of stuff, and then it printed the message, hit any key to continue. And people kept calling the help center to try and figure out what to do because they couldn't get past this problem. Anybody know what the problem was? Yeah?
They couldn't find the any key.
Right. They were looking at the keyboard and there was no key labeled any. Right? And this told them very specifically that what they had to do now was hit the key labeled any, and they couldn't find it. So they didn't want to do anything wrong, so they called up the help center. Right? It didn't really matter what they hit, obviously, but if they'd said hit the space key or hit the Q key, it didn't really matter. If they picked any key, it would have been better than using a name that people couldn't identify with. Another important one is letting the user always be in control and not having the computer be in control. So typically, the easiest thing to think about this is always have a cancel button. So no matter where you are in the middle of your process, you need to be able to cancel out of it. So this often has interesting implications for your architecture, for your data structures, and especially for web-based interactions, that you've almost finished doing something, and then the user cancels out. It shouldn't leave your data structures in an inconsistent state. So it turns out this past week, or pretty much this whole month, I've had to work with a system that violated this principle, and it was a royal pain. We just did this HCI 20th anniversary celebration, and we had a registration system where you typed in a whole bunch of information, and then as the last step you paid. Sounds pretty ordinary. But it turns out, because of the way the CMU architecture was set up, there was no way for the payment mechanism to be tied in with the registration mechanism. So when people finished filling in the first page of the form, it saved that to the database and then shipped them off to the payment mechanism. And if they aborted during the payment mechanism, which probably 10% of the people did, then we'd end up with this record in the database that didn't know whether people had paid or not. And so the result was that me and a secretary had to waste hours of time manually matching up these two databases of who had paid and who had finished entering stuff. And naturally, people had multiple entries because they started off and then changed their mind. Oh, wow, this is going to be more money than I thought. Cancel and then start over. And people who didn't ever end up registering, it was just a royal pain because it violated this principle. And from the user's point of view, they couldn't tell what happened. They were perfectly happy to cancel at any point. But from the back-end architecture, it just was not set up to follow this principle. Similarly, it's great if you can support undo. Very few cameras or very few consumer electronics or web pages have undo. But on every kind of desktop software, you pretty much are required to have it. And ideally, you'd have it on mobile devices, mobile applications too. But again, it's much less common. Kind of like undo is the back button on browsers, right? So it goes back a step typically if you have a multi-page kind of operation. And it used to be that sites would get all confused if you hit the back button and typed in something else. And modern systems have to be more careful about that. And so you rarely see cases where things would get messed up. But I've definitely had cases where I bought something and then I tried to undo it by backing up and that doesn't work. So I ended up with two things or two different versions of something. Or where you're trying to make a flight and you back up past the one part of it and it thinks now you have two outgoing flights instead of an outgoing flight in the back and a different outgoing flight. So it's a lot of trouble in web-based interfaces, but it's still basically a requirement that you let the users back up in order to get to new values. It's basically assuming that you will always have the ability, from the user's point of view, to make mistakes, because everybody makes mistakes. You know, you make typos, you change your mind in the middle of operations. So it's not like this is only relevant to novices. There was this really interesting problem in this product that I was working on that it had this mechanism for filling in fields where if you had a text field, then it would fill it in with the old value, right? Which made a lot of sense. So, you know, ID, and then it would fill it in. And then if you put tabbed into this field, it would be in what's called pending delete mode, right? So that means that the whole text there was selected when you went into the field. I'm sure you've seen this in browsers, right? If you click into the address bar of a browser, instead of just getting a cursor there, you get the whole thing black. And the first character you type, it deletes everything. That's called pending delete. In this product, this ID, if you typed anything at all here, even a space, it would delete the old value and then be waiting for a new value. So far, that seems fine. That seems like what you'd want. But the problem was, if you changed your mind and didn't want to type in a new one, there was no way to abort this operation. That you were kind of stuck there, and it kept saying, well, type in a valid value, because it wanted to check and make sure you put in a valid ID. But no, people, once they deleted this, may not know what the valid ID was. And this particular dialog box did not have a cancel. So people kept trying to click OK, and it kept saying, not OK, you have to fill in a valid value for this field. And nobody could figure out a valid value. And sometimes people had to basically kill the whole program and start over because there was no way to cancel out of this dialog box. So that was really a bizarre design decision that you basically get stuck at this one point in the interface. Actually, there's some video games where you can get stuck too, which is kind of the same idea. You get into some weird situation that they hadn't anticipated. Consistency in standards is a really big one. It's very important, also very hard to apply. The general idea is that the same command should always do the same thing throughout the interface. Also, the same word should always mean the same thing throughout the interface. So it applies to locations, it applies to names, names of commands, names of products, names of features. It helps give the user a mental model of the system if everything works the same way across the entire interface. So, if you have a, remember we had this discussion of modes. You don't want to have modes where the same thing means different things in different parts of the interface. For example, if you have a camera or consumer electronics and you have a abort button or a back button, it should do back everywhere, right? If you have a watch and you have a button labeled light, then it should turn on the light no matter what mode it's in, right? So there's often violations of this in tiny electronics because they want to, because there's not enough buttons, and so they're trying to say, oh, well, this button will do something in this situation and something else in a different situation. And that's always really confusing to people because they can't remember which button they're supposed to push at this point. So really, it's very, especially for commands, it's really hard to abide by this in tiny interfaces, but it's definitely, whenever you do violate it, it's going to be trouble for people. Another issue is what word you use for different operations. So if the word for bringing up a window, if bringing up one window is under the view menu, then people would expect all the windows to be brought up by the view menu. Or if you wanted to have some sort of settings that people can use, then they should be able to do all the settings in the same way. And most modern interfaces violate this all over the place. That there's some windows that you bring up from the view menu, and some windows you bring up from the file menu, and some windows you bring up from the properties menu. Another aspect is locations. Where do I find the cancel button? It should be in the same place throughout the entire interface. Where do I find the information about what page I'm on? Where do I find the back button? So all of those kinds of things should be in the same place. Color is another example. What does red mean in my interface? Or if I have a button that's blue, what does that mean? Is it just decoration? If some buttons are blue and some buttons are purple, what's the difference between the blue buttons and the purple buttons? So you may think as a designer that you're just being decorative, but as we talked about in the design lecture, the user is always trying to come up with a mental model of your system. They're trying to apply meaning to virtually anything they see. And so even if you didn't intend for there to be any meaning to this decoration, they're going to assume there is one or try to invent one. And so that obviously just is going to get you into trouble if there really isn't some meaning behind the scenes. Things should be in the same order. If in some place I have to put in my zip code before I put in the city name, that should be done everywhere else as well. So you expect everything to be in the same order. The example I have here is about the color purple. So I was consulting for this one company that was making alarms. It was an industrial company, and it was this big conglomerate. And they had bought another company. Right? So now there are these two companies which have long historical sets of products that were already out in the world. And pretty much everybody agreed that red was really bad, that was a high fault, and green was normal, and yellow was in the middle of things that are warnings, but not yet critical. But the two systems also had purple as a level of problem, right? So there was a purple alert. And so the issue was, where should purple be? Okay? So how many people think it would be better for purple to be between red and yellow? 3, 4, okay. Everyone has to vote. How many people think purple should be between yellow and green? Oh, come on. Everyone else vote too. Should we do it again? There's a few more people for that one. It turns out in these two products that one of the products did it one way and one of the products did it the other way. And so the people on each side said, we have to be consistent with the way our users are always expecting this to be. Right? So it would be really bad if all of a sudden purple switched from being in one place versus another. So this is how they ended up. So you can imagine if you're in a factory and in version 3 of your system, purple meant everything's pretty much okay, and in the next version of the system, purple meant things are about to blow up, right? You really wouldn't like that. On the other hand, now they had this integrated system, and they were hoping to go to a place where people would be using both of these products together. And that would be even worse if all of a sudden from one page you had purple and another page you had purple and they mean totally different things. So this company was really stuck. And eventually they decided to go with consistency in the current interface and just have some giant warnings for people who used one version that this had now changed, because it was just too dangerous to have it not be the same across the whole system. So that's an example where consistency across the system was more important than consistency with what people already knew. But definitely, if you're doing a product that's going to work with Microsoft Office, then you pretty much have to be consistent with the way Microsoft Office works, or else people are going to be very confused. Right? If you decide, oh, I don't like the way Office does stuff, I'm going to put all my menu items in different places than Office does, then users moving from one system to another are going to be really confused. So there's this consistency with other things as well as internal consistency that you have to take into account. So here's another example of internal consistency problems. So in one part of this system, they had this fairly complex naming scheme for their parts. So I don't really remember what the pieces were, but there were basically 4 sections to their part numbers. F number 1 dot C number 1. And that's how they did it in half of the system, and in the other half they did it F number 1 comma C number 1. So that was pretty confusing, because if they had a text input field where you're supposed to enter it, then you have no idea which of these formats to use. And secondly, users would assume, because they see it this way in one part and this way in a different part, that there's really some important functional difference between those. But really it was just sloppy programmers just making up whatever they felt like for how to present this information across different parts of the interface that were built by different people. And so that's obviously a big problem. How would you deal with this? Well, you pretty much have to have some sort of guide or template or style guide or terminology list or vocabulary list for your whole team. Right? Because almost any realistic interface is going to be built by teams, and you need to have some way of making sure all of the teams are doing stuff the same way. So another kind of consistency is with standards. So there's a standard meaning for the word copy in a user interface. What does copy mean? What does copy mean in a computer interface? Yeah? I'm sorry? Copy text to clipboard? Right? So what does copy mean on a photocopier? What? Yeah, it means duplicate, make another copy, make a piece of paper, right? But you can't use that meaning of copy in a computer interface, right? It makes perfect sense that if you said copy on this thing, you'd get another one. But that's not how it works. To get another one, you have to do a paste, right? Copy by itself does not create a copy. What is the word you would use in a computer interface if you wanted actually another item of the same kind in the interface? No. What? Duplicate is the typical term. Clone is very technical and has other meanings. But if you had if you wanted another file with the same, that's a copy of the current file, you would call it duplicate. Right? If you wanted another document that's the same as the current document, you would call it duplicate. You can't call it copy. And this is, doesn't make too much sense, but you have to follow the standard in order to be consistent with the way everybody expects interfaces to work. The next one is error prevention. So you ideally don't want your users to make mistakes. And so the idea of error prevention is to try and figure out ways of minimizing the opportunities for people to make mistakes. So to try and avoid mistakes in the first place. And the next one we'll see is a way to help people figure out what to do. So one of the ways of avoiding mistakes is letting people select things rather than do text entry. So you see this an awful lot in calendars, right? So if you want to enter a date, usually people will pick from a calendar or for drop-down menus. Similarly for years, instead of letting people type in a year, you almost always have to pick from a list or states of the United States. Anytime there's a reasonably small number of items, you can let people type it in. In Expedia and many other travel sites, if you just type in Columbus, that's ambiguous as to what city you want. And so rather than trying to get people to type more, which would be another level of difficulty and source of mistakes, it gives you a list of the 3 Columbuses that have airports and lets you pick which one you want. In regular interfaces, you would remove or gray out illegal choices so people can't pick them, right? So most interfaces, if nothing is selected, you can't get the copy command. So on a desktop interface, it would gray it out. On a phone interface, then it wouldn't be in the list of things that you can do. Right? So typically, it would either be grayed out or removed. But on a physical device, like a camera or a remote control, there's no way to gray out or remove a physical button. Right? And so the trick with that is then you have to make those buttons do something useful. Right? So I have a remote for my TV at home, and when you're setting the date, you are not allowed to use the number keys, right? So they're perfectly good number keys, and I want to type 11 to mean November. It doesn't let me use the 1 key. It doesn't gray it out. It doesn't remove it from the remote control, obviously, but it just doesn't work. It makes an error. Instead, you have to use the arrow keys, which is kind of stupid, right? And so another way around this is to try and make sure that anything that the user might want to do does something reasonable, especially when you have physical controls you can't remove. Another thing is auto-fill-in, which all websites do these days. If you type a letter or two, it'll fill in with the rest of the stuff that you might want to type, to the extent that you can detect or predict what might be available. Another way to avoid errors is confirmation, but this tends to be very like a last resort kind of thing, because people just get used to typing yes. So if you ask, do you really want to delete this file every time you delete a file, then people will say delete, yes, delete, yes, delete, yes, delete, whoops, right? Because they've just get so used to hitting yes that it won't have the appropriate level of novelty and the appropriate amount of extra thought that you're hoping you would give people. So ideally, you reserve confirmation for only things that are unusual, and also you provide enough information so the user knows why you're asking confirmation. So we talked about that in the system status one, that the confirmation has to be clear about why it's asking. So modes is another thing to avoid. And the idea of a mode is when you do something, it does something different in different situations. If you have a mode in your system, so cameras, for example, are very common to have modes where the different buttons do different things depending on what mode you're in. Anytime you have a very small number of controls, this is going to be an issue. Ideally in desktop interfaces that you don't have modes, so that you can be much more clear about what things will happen. Some text editors are very moded. Anybody here still use VI or Vim? A couple people. So this is an example of a moded editor where if you type the D key, sometimes it'll enter a D into your document, and sometimes it'll delete something. And it all depends on what mode you're in. And the classic example is from this old mail program that normally you could type daytime, and that would tell you what time of day it was, which is kind of useful command. But if you happen to be in this mail program, what this did was delete all, and it was a pretty good program, so it asked for confirmation. So you say yes, and then you type T, which was ignored, and then you say insert me. So now I've deleted everything, I've confirmed that I wanted to do that, and I have a file now. The only thing left in it is the word me. And so you say, oh my God, I just did something terrible, let me undo. It turns out this system only had a single level undo. So as soon as you hit undo, it would go back to, it would get rid of the last command, which was insert me. And so you're back to the situation where there's a whole document with nothing in it, where you've deleted everything. So it's a classic example of how a moded system can result in the user doing, taking something they do normally and turn it into something really dangerous. So how do you, if you have to have modes, how can you compensate for this? One way is to make them very visible, make it really clear to the user what mode they're in, and also to show really clearly the consequences of any actions. The next one is recognition rather than recall. This means that the user should, it's much easier for people to recognize something than it is to have to remember what it is. So, if you're going to have a way for people to delete stuff, it's much easier to look on a menu and see what it's called, as opposed to having to remember the command and typing it in. So is it called delete or remove, expunge? There are all sorts of words that might be used, but if I'm looking through the menus, then I can probably find it pretty straightforwardly. So the idea is that you make everything visible and you let people click on them rather than having to remember them somehow or search for it. Another way this comes up is sometimes there are interfaces, and you see this pretty evident if you do a user study, where people end up writing stuff down on a piece of paper because they're required to remember it from one part of the program to another. And that's just, clear evidence that there's some problem in this interface, that it's making me try and remember something from one part of the interface to another. So sometimes an expert can get around this with copy and paste, but typically novices would not necessarily think of that strategy. So ideally, you would be able to move any content that people need from one place to another automatically in the interface. There's this classic example that people can remember about 7 things, which is why phone numbers used to be 7 digits long, because that's kind of the level at which people can remember stuff. But the problem with assuming that people can remember something like this is that as soon as they're interrupted, the phone rings or whatever, then they're bound to forget it. And this is short-term memory, so people won't remember it for very long anyway. So the interfaces should be designed so that people don't necessarily have to remember anything at all. Other aspects of this is that people should not have to remember what format your system is interested in having people enter stuff in, so they should be prompted for that. So whenever you have particular requirements for formats, then it should say that very clearly. And this comes up all the time in web forums, which say phone numbers do not put in spaces or hyphens, or credit card numbers, don't include any spaces or hyphens, which is really annoying because from a programmer's point of view, it's really easy to remove those, to just delete the spaces or hyphens. And the reason that they're that way on credit cards or on phone numbers is because you can remember things in little blocks much easier, and it's much easier to read. So if you're looking at a credit card number on your credit card, they're in blocks of 4, because that's really easy to remember the block of 4 and then type that in the next block of 4. And you don't get these errors where you're missed a digit. But to the extent that anything is required, this kind of formatting, then you should prompt for it. Another thing that comes under this is to have pervasive generic rules. So then you don't have to remember how to do different kinds of things in different parts of the interface. So that's another way of avoiding having people memorize stuff. Over here, I click this button in order to go back, and over there, I click this other button. And that would be something I'd have to memorize, about the system that I use all the time. So pervasive generic rules. And if you remember, in our initial lecture, we talked about the Aegis system, where the operators were required to remember the altitude and compare it in their head to the new altitude to see if the planes were going up or down. So that was an example where the system required people to memorize these numbers and do some math in their head, whereas a better interface would not have made that requirement. So they could just recognize it rather than recall. In the print dialog, it has always said an example of the formats that are possible. So most people don't know that you can only print a range of pages or a selected set of pages. But every time you print, this very subtle little prompt is here that will tell you that. So if ever it comes up, it's not like you have to remember the format. It's right there in front of you. So that's an example where it helps to make it really clear what are the choices. So these guidelines are for experts as well as novices. And this one is particularly focused on expert use. And the idea is that there should be things in your interface that help the experts do their jobs more effectively. And so they don't necessarily have to use the long, slow method that you have provided for novices and new people. So there should be shortcuts in a web interface or consumer electronics. That might be a way to jump directly to the page I care about, as opposed to having to go through a long series of pages on the way. Another example is command keys. So on Office, you can use special commands on the keyboard to execute commands right away. So everybody probably knows the command key for copy, right? What's the command key for copy? Right, and for paste? So why isn't it, so paste is Control V, because way back in the early Macintosh days, they decided P was better for print, and V was better, and V was left over, and so they used V for paste. Right? There's no particular reason that it should be V. It makes no sense really, but it's it's one thing you memorize and then you can use it everywhere. Yeah. That's a great question. So does anybody have a keyboard that's a different language? Anybody? No? In Chinese, it's what? Control.
Control wave, okay.
Okay.
Everything's the same.
It's the same.
I thought the reason you could use is easy to see control. I thought that's why they chose.
It could be. C and V are next to each other, and so they just picked V. As a leftover letter that was nice and close to C. Yeah, so you don't have to move your fingers as much. I mean, that makes sense. It's plausible. I'm not sure if that's true or not, but in terms of mnemonics, most of the command shortcuts are the letter, a single letter. And the decision to make P print instead of paste. How many people use print as Control P instead of the menu item? So yeah. But you print a lot less often than you paste. So maybe that was a good decision, maybe not. At this point, everybody's memorized it already, so it doesn't really matter. So that comes under consistency, that you have to do it the same way as everybody else. It comes under the shortcut idea, and that there should be shortcuts for everything. So probably on PCs, people probably know that if you type Control-Tab, that will get you to a different application that's running at the same time. But most Mac users don't know that that works on their Macs. How many people know how to switch applications with just the keyboard? Okay, so many people do. It's basically Command-Tab, right? So they took that right from the PC and mapped it into the Macintosh. And there turns out to be lots of accelerators you probably don't know about There's ones for switching windows and bringing windows to the front and iconifying things. And it turns out on a PC, almost everything has a shortcut command. On pop-up menus on the web, you can usually type the first letter. So if you're trying to get to Pennsylvania, usually it works really good to pop up the menu and then hit P, which often will give you Palau, which I'm not sure what that is, but P is Pennsylvania is directly under that. So there's all sorts of accelerators. Another thing that comes under this is if you've logged in, it should put all of your information in the right places as you go through the forms on a web page. So when I get to the shipping information, it just fill in all the shipping information. If I'm buying something, what should be the default for how many I'm buying? Right? It should be 1, right? There's no reason that you should be required to enter 1 as the number of things you want to buy. And yet there are some e-commerce sites that leave the quantity blank and require you to enter the quantity you want. So if there's a reasonable default that's true for most people, it should just be filled in. Lots of cases where you can apply this rule to give good default values. And any time people have entered information, it should be saved in order to be used later. So what's a reason that you might not do this? That you might violate this principle on purpose? Yeah? Yeah, so sensitive information, security reasons, right? You don't auto-fill in people's passwords for them, even though you know what it is, right? From the application's point of view. People can set that up so their browser will do that if they want. Or another example is your credit card number. Sometimes websites will remember that for you, and sometimes they won't. Right? So US Airways actually just switched. Originally, they would not save anybody's credit card numbers, and now they do. And so the issue is they're setting themselves up for people trying to steal credit card numbers. Right? So if they have this giant database of credit card numbers, that just gets to be something really attractive to thieves. So that's the reason why they might not want to save it, but it's a lot more convenient if you can just pop up the information about what you used last time. So there's a whole bunch of things that come under this category. It's really 2 totally different concepts. Aesthetic design is following all the design principles that we talked about last time, and minimalist design means not having extra stuff on the screen. So they really don't have much to do with each other. You can kind of tell that Jakob Nielsen came from the CS point of view. He's actually a trained computer scientist and not a trained designer because there's so little of these heuristics that have anything to do with design aspects. And they're kind of all lumped under this one category. So good graphic design and color choice. Some of the subparts of this are that people's attention should be directed to the right things. If you have something blinking, people are going to look at it because they can't really avoid it. If something's blinking in your periphery, you're drawn to looking at it. Things that are on a black background with white text in a field that's white with black background is much more compelling. So you want to make sure that people are only looking at the things they're supposed to be looking at in the right order. Grouping related objects together and making sure that your decorations and the outline boxes and so forth helps with that. Balance and white space, to make the page look appropriately balanced, or if you have it unbalanced on purpose, like we talked about before, that's important. Maintain display inertia means that as you're going from page to page, things shouldn't just randomly wander around. So, for example, if you have an icon and you go from page to page, it should stay stuck in the same place, like a logo or whatever. It shouldn't just move slightly here and there. Don't use very many fonts and colors. Have appropriate contrast. So this is from an actual screenshot. How many people can read what this says? Right? People in the front can read it, but people in the back have no clue. Whereas this is pretty easy to read because at least you have a dark text on a light background. But this says device synchronization. But if they'd made it white text, it would have been much easier to read because there's not enough contrast between the foreground and the background. Anybody in here colorblind? So 8% of males, yeah, so we got one. So typically in a class of this size, there'd be 1 or 2. And that means that things that are encoded in red and green often look gray. And you can't necessarily tell a difference. So that generally means that you have to multiply encode things. So encoded not just by making it red, but also by putting a star on it or something like that. So because color is very, stands out a lot for people who don't have this issue, you don't want to forego using color. So it's still important to use color for the 92% of people for whom this helps a lot. But for the small number of people who it doesn't help, then you should have something else as redundant encoding. And basically, kind of all of the aesthetic things that we talked about in the design lecture go under this category. But minimalist design means everything that's on the page should have a meaning. Don't just throw in random stuff for fun. Ideally, you would have fewer choices. So there's this current mantra or design goal of designing for mobile first, and we'll talk about that in the mobile lecture. But the basic idea is that if you're designing for a phone, then you're going to have to put the most important items on the front page. And then you can think about, well, maybe we should do that for our full-size interface as well. Right? What can we leave out? What is really important to have for this feature, for this system, and what can we just leave out altogether? One of the ways that in my consulting I've often helped companies think about this is talk to the tech writers, the people who have to write the manuals. And the people who have to write the manuals kind of know what's hard to explain, because that's their job, is to try and explain this in a clear way. Or the trainers, if you have trainers that help with your software. And then a good strategy is you ask them, well, what is hard to explain? What is hard to write down how it works? And then instead of making them try to succeed at that, figure out if there's a way to redesign the feature so it's not hard to explain anymore. Right? Why is it that this is hard to explain? Maybe it's some inconsistency with something else, or there's some weird quirk to the way it works that you could fix. It turns out in a lot of cases there is knowledge in a company about what's hard to explain, what's not working very well, what they're getting a lot of calls to the call center about, things that people are confused about. And by understanding that, you can typically fix it and save a lot of money and a lot of effort on the part of the users. Another kind of aspect of this is to try and make your messages really short. Right? Error messages, prompts, any kind of text that people have to read should be very concise, especially on computers. And people just hate to read large blocks of text. So if you have something that you think you need this big help message about, or a really long error message, then probably you should redesign the feature so you don't need such a long message. Extraneous pictures and information, often you think, oh, I'm going to decorate this up, or I'm going to add adjectives to make this clearer or more interesting. If you take a creative writing class from the English department, they're going to say every time you introduce a character, describe them differently. Try and make this interesting by never saying the same thing twice. And this is basically the opposite of that. Anytime you see something, it has to be done exactly the same way, nice and short, and that makes it consistent, and it also helps follow this principle of being concise and direct, and makes it clearer what to do. So how can you reduce options in your menus? How can you make stuff automatic, or ways that it'll do the right thing? If you have multiple different ways of doing something, that means the user has to plan which one to do. This comes up all the time in word processors and drawing programs. Right? There's 6 different ways of selecting something. I can drag through with the mouse, I can use the arrow keys with the shift key, I can drag a box and select things, or I can click on them individually with the control key down. And which one of these are you going to use? Well, the user has to then have a strategy for figuring out which one to use. If there was only one of them, then there would be less choices. But then it might be inefficient for experts. So this is an example where there's this trade-off between the previous principle of making it easy for experts and the minimalist principle of making it so there's not so many different ways to do stuff. And to the extent that you have a manual or something, if you're building a software product or consumer electronics product, pretty much everything that the thing does has to be described in the manual. So if you could leave something out, then that makes the manual smaller, and it means less that has to be described. In this one product that I was evaluating, there was this menu item that was show cartouche, and it was grayed out. So I asked the designers and the implementers what it meant, and they didn't even know. So eventually I discovered that there had been one client in the distant past who had asked for this feature and spent extra money to have the company put in a special feature for them. And that was the only company that ever wanted it. But they left it in the menus grayed out for everybody else anyway. And as a result, the manual had to say what this was for. It had to describe what a cartouche was. And there was a lot of extra text that was not relevant to any of their current customers because nobody had this feature anymore. And they wouldn't have even known how to implement it because the guy who had implemented it had left the company anyway. But it just stuck around for historical reasons. So it's an example of where this principle would say just throw it away, don't make people try and understand it or have to skip over it in the menus. Number 9 is about helping people when they have errors. So help users recognize, diagnose, and recover from errors. So if you think about when the user's made an error, right, they're not in a happy state, right? They have gotten to a situation where something they wanted to do is not happening. So this is really not a good place for humor or for for making them do problem solving. Right? They're already frustrated that they got into the state that they didn't want to. Something that they wanted to do isn't working. And so what you need to do is think of errors as a way of educating people about what they did wrong and how to fix it. So it's in some sense an opportunity for you to explain what the user's misconceptions were. Why did they think this was supposed to work? Or why did they think this entry into this field would be okay? They typed the country into the state code, the state field. Or, so having very clear and precise error messages is going to help them understand what they did wrong and teach them how to do it correctly. So, for example, syntax error. Right? If you ask an English major, what does it mean to have a syntax error? They're going to say, oh, well, that means I put the verb and, the verb doesn't match the noun or something like that, right? Which is nothing like I put in my telephone number with hyphens instead of spaces or something that a computer would think about. So using generic computerish words for your error messages isn't very helpful. So you want to constructively help the user solve the problem, tell them why it happened and how to fix it. So a typical example that comes up in desktop applications is can't save file. Right? So why can't I save the file? Do you think the system knows why you can't save the file? Right? Of course it knows it, because somewhere in the operating system it has found a problem. What are some reasons why you might not be able to save a file? Yeah?
No access to the disk.
Yeah, so the disk is write protected. Say you have a CD that's write protected. So that might be why you couldn't save a file. What else? Yeah? It could be full. It could be a perfectly reasonable place to write it, but it turns out currently to be full.
Read-only mode that doesn't allow saving.
Right, so the particular file you picked may be read-only, independent of the disk itself. What else? Yeah, that's a good one. So the name has a colon in it or something you're not allowed to use in the name.
Name
or the file already exists and you're not allowed to overwrite files. So there's a whole variety of reasons why you might not be able to write a file, and the thing that you would do is totally different depending on which ones there are, right? So if it just says can't write file, then you have to go through this list and try and see which one it might be. And of course the operating system at some level has detected which one of these it is. And so basically what your user interface is telling to the user is, nah, 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 I know the answer and you have to guess, right? So it's just kind of being annoying to the user without, because it's easier for the programmer. At some level it just passed up a failure, and rather than do the work of figuring out what the failure is caused by, it just passed this failure up to the user. Another aspect of this is being polite, right? So fatal error. You made this error and now you're going to die because you're fatal, right? There's a fatal error. It's not really that the user is going to die, right? You can't have software like that. Maybe the software is going to die, but it's just a ridiculous thing to say to a user that this is a fatal error. Another aspect of this is to blame the system and not the user. So it's the kind of difference between unrecognized and illegal, right? Illegal command, you're going to jail, right? Because you typed in this illegal command. It's much more polite to say unrecognized, right? I didn't, I'm a dumb programmer or a dumb program and I didn't quite catch what you meant. Maybe you could try something else. Again, no humor, snide comments. It's pretty, the programmer might think it's funny to give an error message at this point. And sometimes it's funny to the user once. But one thing about humor is it's not funny the third time, much less the 100th time. And even though the programmer only has to write this once, users may run against this error over and over and over again. And so, that's a problem with humor. Also, there are a lot of cultural differences in what people find humorous. And so if you try to do something funny, it might be insulting to some people. Snide comments, have no place in a user interface anyway. No sarcasm. Programmers like to be sarcastic, but it's really not a good idea in a user interface. There always should be an easy way to recover from errors. So that's another architecture issue in terms of your data structures, that no matter how messed up the user gets, they still should be able to cancel out and start over. So that's part of the design. Sometimes it's useful to have multiple error message levels. So typically these days, a user, if they don't understand the error message or what to do about it, will type it into Google. So allowing people to copy and paste the error message is helpful, because then they can do a search, and very few error dialogues let you do that. Sometimes there should be a button that will give you extra help about the message if there is it. So here's the can't save file example. So here's some examples of bad error messages, and I'd love you guys to send me more of these, because a lot of these came from the class. Error 500, unable to process your request. Oh my, this is awkward. Sorry, sweetie, but something has gone wrong, an unexpected problem happened. So this is kind of cute the first time maybe, but the third or fourth time it'll get really annoying, and there's absolutely no help with what it could possibly be that's gone wrong, right? So I have no idea what to do about this except try again later. Here's an example where Fujitsu just never got around to writing the error message, and so they had this placeholder that they forgot to fill in. And obviously that's just silly. Eventually somebody's going to run across it. Internal error, could not process your request for registration, error 917. A good thing I got a 917 error instead of a 918 error, or else I'd be really confused, right? So, these error codes are totally useless to people, and I have no idea, something was required that I didn't fill in, but it looks to me like I filled everything in correctly. I have no idea what to do. Here's another example. This number cannot be registered in the uPromise service at this time because either you entered your information inaccurately, or you already registered this number, or this number is not valid. Do you think the system knew which one it was? It wouldn't. I had no idea what to do about this, so I eventually had to call the store. And it turned out the problem was that my wife and in the Giant Eagle, you can get multiple cards, and they actually can have different numbers and map to the same account. And so I was trying to enter my number in which I knew I had never entered before, but what happened was it matched the same account as my wife's number, which is different, and you were only allowed to do one of those. That's none of these choices, but if it had said that number had already been entered, I would say, okay, well, good, I don't have to do this, right? But because it had such a vague error message, I had no idea what the real problem was. Your request, thank you. Your request resulted in the following message: invalid tranche ID specified. Well, I can promise you I never typed in a tranche ID. I don't even know what that means, right? And does this mean it worked or it didn't work, right? You have no idea from this what's going on or what to do about it. And so in Yahoo, this is an old example. If I apparently typed in the arrival city or airport is required, please check it. So it turned out I had forgotten to type in the place where this is going. The copyright is actually on the slide and not on the window. Oops, come back. Shoot. Well, whatever. So what they do now, it's not any better, it turns out, is that Yahoo stopped having its own travel site and instead using a company called Hipmunk, which, by the way, is a really cool company. I definitely recommend the site. But if you type it in incorrectly on the Yahoo page, now you go to the Yahoo page and it says error. Oh, nuts, we couldn't find that location. So again, I'm completely confused because I did type in a perfectly valid start place, and I just left the end place off altogether. And by going to a totally different page, now I don't know what to do at this point, right? Am I supposed to go back to the Yahoo travel site and then type in something different, or am I supposed to do something here? So this is a case where it's actually gotten worse over time. Come on, wake up. And the final one is help and documentation. And this includes a whole bunch of different aspects of the content that you actually have on the page itself. So the basic idea is that you need to be able to walk up and use the system, and it should be self-explanatory. If you have documentation for some kind of consumer electronics, people typically will not read it, or maybe they'll read it the first time they get the device, but never read it again later. They can't even find it anymore. But it turns out the documentation itself is very hard to write clearly. Has anybody ever tried to use, IKEA furniture or, a consumer electronics device from China where the instructions are pretty hard to read? It's not unusual for instructions to be complicated, so typically you'd need to iterate to do user testing and the kind of stuff we're doing in this class on the instructions as well, separate from doing it on the product, because the instructions can be confusing too. I've often, sometimes when I'm consulting, people say, oh, we don't have to make this simple, we'll just have a help document that will tell people what to do, or a help button on that menu or something. And the answer to that is help doesn't. That it's nice to have help when people need it, but you can't rely on it, because typically people who are confused don't find the help at all helpful. And it's important to have quality writing. Don't use this as one of the homework 5 criteria, because it's going to turn out that nobody in the class wrote any documentation for their system. And so if everyone says, oh, the prototype has no help in documentation, well, that's just trivial and not very interesting. So you probably should not use this as one of the comments for the homework. So here's a good example. The NSF site, for every question, it has both a what and a why button to tell you why they're asking for it and what you're supposed to put in that field. So for the homework, you're going to have to do this. Maybe I'll just wait for these 2 slides and do it next time, because then we'll have the homework in front of us. So I'll postpone the last 2 slides, 3 slides to the next lecture, and we'll talk about how to apply this to the homework on Monday.